Welcome back to Mining Now. We're filming more episodes at PDAC. Very wide range of people being featured on this show with some amazing companies. I'm your host, Jared Downey. Today we have back for a second time. First time on Mining Now, second time on with Crownsman. We were going to have Atri Maharaj. He is the manager of characterization at Anton Paar, and we're going to be talking specific to the mining industry, mining sector for Anton Paar. Atri, sorry, wow, my.
It's not a common name. I'm really used to it. I've heard every derivation possible.
So is it better when someone doesn't correct themselves or when they do?
To each his own. I roll with the punches on a daily basis. As you can imagine, in my role as a manager and when I was in sales as well, I've traveled all across Canada. It's one of the most beautiful things I've been able to do in my job is meet people and say I've been to every province in Canada.
Really?
Yeah, that's what the
my
job
wife
is
and I were
me.
just talking about the one that we haven't seen yet. But you've been to everywhere.
Well, almost. I haven't been to PEI.
You haven't been to PEI?
Not yet.
Oh, no. Well, the PEI audience is going to go after you now.
they probably are, but for good reason. I did exclude them a bit, so I'll take my comeuppance when it comes back to me.
Let's talk, let's clarify, because we have had Anton Paar on before, but different audiences are always watching different episodes.
Sure.
So I kind of always want to go off the assumption that maybe a lot of people in the industry are going to know Anton Paar. But for those who don't, can you give the high level of who you are as a company and then the specific of the mining section?
Okay, sure. So Anton Paar, we are a multinational company. Our global headquarters is based in Graz, Austria, and we have 38 sales subsidiaries across the world. I'm very happy I said that because we grew by 2. Usually I've been so used to saying 36, but now we're at 38 sales subsidiaries around the world. We manufacture analytical instruments that are used across a wide array of industries. Mining is where we are today. That's where we're going to be focusing a little bit. But another thing I enjoyed, other than getting to almost every province, said it that right that time, almost every province in Canada, is the vast array of industries that we serve. So in the morning, I'd be working with someone in the cannabis industry. In the afternoon, I'd be talking to somebody manufacturing foods. Academia is very much at the heart of what we do because this is where a lot of R&D really starts for many different industries.
So a lot of collaborations with universities and
yes. Globally as well. I think if I remember the stat correctly, it's 95% of the top 100 universities in the world use Anton Paar instruments.
Really?
Yeah, because not only because of the quality of the instruments that we produce, but also the breadth of the portfolio. So we're very well known for our density and concentration measurements. Density and concentration, refractive index, polarimetry. For some people, you kind of speak in Greek at this point.
Yeah.
But when we have 15 different product lines from in areas where I'm more well experienced, like particle size, small angle X-ray scattering, X-ray diffraction, something popular in the mining industry as well.
Okay, how long have you been with Anton Paar?
I've been with Anton Paar for 6 years now. I originally started out in Calgary, moved from Ontario to Calgary. During COVID, the opportunity arose to bring me back home to my wonderful home province of Ontario. Jumped at the opportunity therefrom, and so that was back in 2020. And I've grown with the company from sales into sales management over that time.
Let's talk about our heavy industry tour brought to you by Savannah Equipment, supplying mining equipment worldwide, and Corporate Traveler Canada, helping companies travel the globe simpler, faster, and easier. We are heading to events across North America, Africa, and Australia, and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Your trusted partner of choice, Bestech Engineering, is excited to announce that they have acquired Spencer Engineering. This allows Bestech to add mine hoist expertise to their existing suite of services, including mining, power, electrical, instrumentation and automation, mechanical, and structural divisions. This diversification will offer clients the highest level of service and value for their projects. Don't miss out on this exciting new chapter of engineering excellence. Reach out today at besttech@besttech.com to learn how Bestech can help you. The CIM 2023 Convention and Expo is coming to Montreal from April 30th to May 3rd, so join us in recognizing your peers at the annual CIM Awards Gala. This year is extra special because CIM is celebrating its 125th anniversary. There will be special programming and perks for exhibitors and attendees alike. Registration is now open and tickets sell out fast, so visit CIM.org to register now for short courses and explore sponsorship opportunities. Hexagon's technology and solutions enable stakeholders across the mining industry to make better decisions faster. Get smarter integrated cloudware, sensor software solutions, and in-field apps that connect mines to boardrooms in real time. Hexagon offers safer, autonomous, more sustainable open pit and underground mining solutions spanning exploration and planning, safety, and operations. Visit hexagon.com/mining or email info.min@hexagon.com today.
So what do you think, what do you see as the company's sort of through line in just the way they expand and move so efficiently in the market?
So Anton Paar as a company, we have been around for 101 years now. I love saying that. It sounds even more prominent than 100 years.
You made it past that.
Right. And we're continuing to push on with this. So we celebrated our centennial last year. And one of the greatest contributing factors into this has been stability. So we're a family-owned company. We're a family company. And one of the biggest contributing factors into that stability has been the fact that we're owned by the Thickener family foundation. The rights to the company were irrevocably transferred to the Thickener family foundation, which is also a charitable foundation, not just a holding company for Anton Paar. So we focus on running the company and also charitable initiatives,
right?
Such as addiction treatment. That's one of the major thrusts with with the family.
I didn't know about that. Wow.
Yeah. And another contributing factor is our roots came from high precision manufacturing. One of the first things we manufactured was in collaboration with a university in Graz, Austria, was the Kratky camera, which eventually became what we call a very specialized instrument these days called the SAX, which stands for Small Angle X-ray Scattering. So the Kratky camera, the professor is looking for someone capable of manufacturing something with very high precision. Because when we're looking at things on the angstrom level, we need this uber level of precision behind it. And that's what Anton Paar and his daughter Margarita worked on 101 years ago.
101 years, that's amazing.
Got to catch myself into that. So having our roots in this high precision manufacturing, most of our parts are manufactured in-house. So as many people were affected by supply chain over the last couple of years, we have 3D printing, additive manufacturing in-house. Even the screws on our instruments are machined in-house. I would say, I don't remember the stat exactly, so don't quote me on this, but I would say between 90 to 95% of our parts are manufactured in-house.
Wow.
So that again contributes to our stability, and very thankful over the last couple of years that we haven't been that affected by supply chain issues.
We'll get a stat on when you're saying that part. We'll get a stat to give the exact thing on the screen.
Put it in bold, right? You know, so that marketing comes back at me later.
Yeah. So on the, I want to switch over to the. By the way, that was a great explanation, because sometimes when you ask the question of that, it's hard to get context. So it's really important. And now moving into the mining side, I want to touch on sustainability first before we get into some specifics. Because I would imagine with what Anton Paar is offering, that's a huge focal point in the conversation. Do I have that right?
True. Sustainability is a word we hear a lot across industry these days.
Yeah.
Everybody talks about sustainability. And one of the interesting things I think about sustainability is what was previously considered waste is suddenly very, what's the word I'm looking for here? Salient to what production, manufacturing, and everything else is moving forward. And you hear this a lot bandied about in mining as well, sustainability. It's a buzzword. What people tend to forget is that mining has been at the forefront. They've been at the leading edge of sustainability for a very long time. When you think about things like water treatment, water is not something that is a non-perishable resource. It's something that needs to be used very efficiently, given how influential it is in every process at a mining site. So many of the techniques used in mining, I wouldn't say they were pioneered, but they were thought about. And mining is a conservative industry. They're very focused on margins. as many people are.
Well, because it goes back to every piece in mind. The major pieces are, it's such an ordeal.
Yeah.
Just to get that ball mill to start turning.
Exactly.
So you don't get to have 10 ball mills. You don't get 10 cracks at it. You get one, you know?
Yeah. And when these technologies and processes have proved themselves out in an industry like mining, and then it goes to other industries, you know, people kind of forget where the root is behind it. So it's one of the things I really appreciate about the mining industry is their focus on sustainability. Maybe they haven't thought about it in the early days or captioned it as such, but they've always been at the leading edge. One of the most inspirational things for me in mining these days is that as you look towards the electrification of mining sites, trying to create this closed circuit, you have solar panels, you have windmill turbines, etc. out there to help generate electricity, kind of take them off the grid. They're somewhat self-sustaining on the power side of things. Is they're also looking at hydrogen. Now, as you can imagine, diesel power has been the main driver for a very long time because you know what you get with diesel. You talk to a lot of people in the mining industry, you know a Cummins diesel engine.
Right.
And you know what you're getting behind it. Now, one of the drawbacks to this, especially when you're sending something underground, is in a diesel engine, one of the materials produced from diesel engine is the sulfur in the fumes and the exhaust that come out. Probably a better way to say this, but you know, I'm not a car guy.
No, that's okay.
I love Formula One, but I couldn't tell you a turbocharger from a carburetor.
Did you love it before the Netflix series or after?
Oh, way before, way before.
I feel like there's a lot of new fans right now.
There's very many new fans around there. Now, when that sulfur is ejected in the exhaust, you can imagine when you're underground, that's not good for people down there. We can't be sending people down in a halo suit.
Right.
You know, it would be great to protect them from everything else and fumes, what have you. But, you know, it's not where we are right now. So that sulfur content has always been an issue. Now, when you're running hydrogen, all hydrogen is putting out is water vapor, which you're already going to have in a very humid environment in any mine. So there's a space in society, there's a space in industry today where batteries and hydrogen coexist. Now, again, think about this. You're going underground, the battery gets down there, the battery dies. You can't exactly send another battery down. Yeah. By the time he gets down there, his battery dies too, you know, and we're back in a loop here. How do we solve this? And this is where hydrogen is a promising technology. In the next 5 to 10 years, I think we're going to see a lot more hydrogen cars out there. Yeah. And that feeds into the sustainability side of things. So looking at known technologies, solar, for example, windmills, these types of turbines. But again, mining is taking the lead and showing the promise that this, I wouldn't say hydrogen is a burgeoning technology, but it's more burgeoning on the commercialization side. Right, yes. And people are seeing this more now.
That's a great way of saying it. More on the commercialization. It's not a new thing by any stretch, but it is the commercialization of it. I mean, we've done... This is the second episode now already. We're only 3 in today. Gabby hates when I tell the order of what we've done because then the editors. But anyway, it's already coming up and it's going to come up in more episodes. We're gonna get into some pretty technical stuff here in a moment. Yeah. But I wanted to, just so we kind of cover all of our bases, the dewatering and the tailings. I know you wanted to sort of highlight it. Here at PDAC. Yes. So can you give us just sort of the overview of what is being offered in that segment specific to mining from Anton Paar?
Sure. Now, the dewatering process, this is the other part of what's one of the reasons you have the thickener, right? So you have this slurry coming in, as we talked about before, with everything that you encountered in the mine. So the big process that they call that extraction, where you're adding in coagulant and you're forming all the flocks behind this, that whole thing is called dewatering. And the idea behind that dewatering is now all those silts and solids and those flocks that we formed, that they sediment out and they come down to the bottom of the thickener. All of that waste is what they call tailings. Yeah. Now, tailings has always been looked at as the waste from the mining sites, mining projects, however you wish to term it. Now, earlier we were talking about the sustainability in mining. Now, the water treatment is one side of that sustainability that the mining industry has been leading with us, been at the leading edge and understanding how to do this. and treat this water for the reuse. The tailings have kind of been forgotten in some ways. It's very understand how to create these tailings, how to store them in tailing ponds, etc. But again, they're always treated like waste. Technology and society has kind of brought us to the point where now we need to consider the tailings not just as waste, which I think is really cool when you consider that ecosystem of everything feeding into each other. And so these tailings, after all the water's been removed and treated and put back, either released, depending on where you are, like if you're in Alberta, we can't release the water from tailings ponds.
Right.
Legislation is in place for that to happen, but and there's added testing being put into this right now.
That's specific to the oil sands.
But that's specific to the oil sands, correct? Right. But when you're thinking about mining after the water's treated and reused and released where it can be, what's left is this tailing, and usually in some kind of a solid type of material or a paste or what have you. Rare earth materials, crucial for where we're going as a society with technology. They're crucial to advance the technology and to commercialize the technology, manufacture, however you wish to term it. Technology has now shown us that we can take this waste, these tailings waste, look at them, and depending on where it's coming from, like if it's a gold tailing, you would not be able to do much with it because everything's been extracted from it. But in other areas of mining, rare earth materials can be extracted from some of these tailings. And where Anton Paar fits in with this is we have microdigesters. So you can sample this tailing, digest it, and this breaks it down into its constituent parts, run it through another instrument called an ICP, which Anton Paar does not manufacture, but they work together. And now you can see, I have XYZ in there. And then you're understanding, it's always the question in mining, right? What do I have and how much of it do I have? Yes. And that's where I think a lot, especially Anton Paar as an instrument manufacturer, fits in. But working with these tailings, I'm bound by NDA, so I can't go too deep into the process behind
now you say that.
No,
I'm kidding.
I'm kidding. Like I have to put the disclaimer on there. I can't go too deep into the process, but I can talk to it from a high level.
You might have more disclaimers on your episode than any other guest.
It's just going to be all everywhere, right? I don't think you're going to see any of this anymore. But so I won't go too deep into the process behind it, but I can as that frontline screening, you can use our microdigester to before it goes to the ICP or the elemental and analyzer behind this, or you can use another instrument of ours called an X-ray diffractometer. Ours is called the XR Dynamic 500. So again, screen the material to understand what the constituent parts are, understand the structure, etc. behind it, and whether it can go through that process. From a high level, it's called a plasma process. You put it into a plasma chamber, and then you're able to extract the rare earth materials from there. But again, this is part of where I say sustainability has always been in the DNA of the mining industry, and we're seeing it being carried forward even more with waste becoming the future.
Fender Dunlop Usflex belts are engineered to withstand the harshest applications, delivering benefits that solve customer problems via superior rip, tear, and impact resistance. Usflex are extremely strong and robust belts that are difficult to destroy, which is important for heavy-duty bulk material handling environments. Made in their very own North American manufacturing facilities, this revolutionary concept in straight warp conveyor belting is up to 3 times more impact resistant versus competitor belting. Usflex users use fewer belts per year, make fewer belt repairs and replacements, reduce or eliminate belt downtime, and improve employee safety. You can visit FenderDunlopAmericas.com to learn more about their premium Usflex conveyor belting. SafeSite has developed a suite of innovative technologies focused on step-change improvements that impacts vertical mining, shaft measurement, underground mapping and survey, mine rescue, and emergency response underground. SafeSite solutions introduce new possibilities in approach and efficiency while keeping every site safer. SafeSite solutions deliver valuable data that can quickly be turned into actionable decision data that allows effective and safe operation. Digital guide alignment will reduce shaft maintenance costs, underground mapping drone technology that removes shadows for 100% accurate reconciliation, and mine rescue drones that extend the reach and range of responders on surface and underground. Visit safesitexp.com for more info. Okay, so let's give a special thank you to one of our longest sponsors of the show, Savona Equipment. And I'm actually going to hand it over to Jared so that he can give you a little bit more info on Savona Equipment.
Yeah, thank you. Yeah, so I mean, people see them as sponsors, so they'll ask me, kind of who they are, what they are, and just trying to understand the scope of the company. So Savanaugh Equipment is a mining supply company, and they're delivering on the whole equipment supply chain. So everything from the ore processing to underground mining, open pit. They're in hard rock and placer operations. And what they're doing is they're sourcing equipment from all over the world and then delivering it all over the world. Now, they are a Canadian company, so they're based there, but, let's say, I mean, they're selling entire ore processing plants. So there might be a plant down in Latin America, and there's a new mine that needs that plant in Africa or somewhere in the US. So they're facilitating that entire transactions. But they're also delivering, an individual conveyor or a concentrator or a pump package or just an electrical package. So it really is the whole gambit of the mining equipment supply chain.
Oh, that's great then. Well, then you definitely have to check them out if you're looking for mining equipment. Visit them at savanaghequipment.com, where you will find more equipment every day.
Can you grab one of the things you've talked and give an example of a specific example of what Anton Paar, one of your units that would be applied to like an underground mine, like the testing, and paint us a picture of a specific unit?
Okay. So the best way for me to explain this is I'll come back to water.
Okay.
Because water, again, is really valuable to all of us. Again, it's a perishable resource. We wish it was a non-perishable resource, but there are only so many things we can have, right? Now, when you think about water at the mining site, when I was first introduced to mining, I was absurdly confused about what a thickener was. I mean, if you think, just from the word, you go look up in a dictionary or something.
Yeah, you're not in the mining industry. You just walk in and you hear people talking.
Hear people talking about a thickener, and I'm like, okay, I know what this is, right? It's like the same thing to put in the shampoo to thicken your hair or something else like this. And you're just thinking, yeah, we're going to make something thicker. Yeah. Boy, was I wrong. Yeah. And I'm sure somebody out in the audience right now is sitting there laughing, right?
Oh, there's a few probably, yeah.
But a thickener. If somebody goes out and they Google thickener mining, and you're going to get this lovely picture of a mining site, and central to every mining site is this big, I would call it a tank. How would you describe it?
Yeah, a tank.
It looks like a tank. It's just this big tank that sits at the center, and it's really probably the heartbeat of everything that's happening on the site. So this thickener is crucial, and it's filled with water, and that's why we get this, that lovely blue tinge or tint or however you wish to term it from there. And why is it crucial? Because, again, water is that non-perishable resource that we need to use. So when it comes to designing a thickener, you have to think about the inflow and the outflow of this water. Yeah. So you have, of course, pumps that are going to drive the inflow and the outflow of the water. So where it starts, and to the best of my understanding, disclaimer at the bottom, please, thank you. Where it starts, to the best of my understanding, is when you start drilling and you start going into the earth, these large machines, they need to be cooled. So we're pumping water down the hole, very broad description at that point. We're pumping water down the hole there to cool the machinery. Now, when this water comes back out, everything that is encountered on the way down is coming back up with it. The silt, the sediment, some ore in many cases. And in order for the water to be reused, it needs to be treated. So that's where it goes over to our thickener. Now, as it's sitting there in the thickener, we need to know, as I said, how to get it in and out. There are a very special group of scientists called rheologists. And their credo is everything flows. Like, they'll have debates with you. Like, one of the examples they used when they explained it to me when I was learning about rheology is, have you ever been to Europe and looked at the stained glass windows in the cathedrals? You notice how it's really thick at the bottom? Right. Apparently, that glass is still flowing over hundreds of years, and that's what caused it there. It's not that they had a different manufacturing process or were unable to make glass the way we do nowadays. Apparently, that glass is still flowing, even though we can't see it. Wow. So that's what they mean when they say everything flows. Now, when we're thinking about these pumps, we need to get the water in and out. So water going in, fairly easy to think about. But when it's coming back out with all the extracts, let's call it, to generalize, from the mine, it's just this menagerie of stuff. And it's not water flowing anymore. So how do you pump something that's going to be thicker into the thickener.
Yeah.
And this is where the science of rheology comes into play. And Anton Paar, we're well known in the market for our density meters as well as our rheometers. So a rheometer, what it does is it helps you to understand how things flow. So there are two major data sets that you'd look at. One is called yield stress, and the other is called a flow curve. The flow curve we can understand, right? Flow.
Yeah.
The yield stress, probably a lot of people wouldn't be readily familiar with this. The example I love to use behind this is you wake up in the morning and you go into the bathroom, grab a tube of toothpaste. Imagine you squeeze this.
I didn't know where you were going with that. All right.
you gotta give me some bounds here. some leeway, I should say, not bounds. If you bound me, we're gonna have a.
All right.
Anyway, so you grab that tube of toothpaste. You squeeze the toothpaste. Can you imagine, as you squeeze it, all that toothpaste flows out of the tube? It's the most useless product in the world.
Right.
Conversely, you squeeze it and nothing comes out.
Yeah.
Most useless product in the world. So that yield stress, when you measure that on the rheometer, it tells you how much, I'm generalizing here again, forgive me rheologists, you're generalizing how much force is applied to deform this to make it flow out.
Right.
Right. And so that's what tells us more with our pump. So we want to know how it flows, and more importantly, the power that's required to make this flow. Because again, if we don't get the inflow into the thickener, we don't have any outflow to cool it, and then we can't be bringing in new water.
So I just want to clarify, is this a real-time instrument that's attached, or is there another? Because if the density is changing from, let's say, one period to another, depending on what's coming in, or is this for a consistent density now that you're measuring on a continual flow, if that makes sense?
So I apologize, I confused you behind that. So it's not a study of the density. Density is one property of the...
It's the pressure that's needed to move.
Right. It's more the force that needs to... So we're thinking about the flow more than anything.
Right.
So,
does that change? Is that just a pressure thing, or it's also the materials that... Right?
It's both. They feed into each other.
Right, yeah.
So one of the things when I speak to people either in academia or in industry, and they say, can your instrument do this? And people want to shoot me sometimes when I say it's sample dependent.
Right.
And that's what we get in this case as well. So when we're looking at this yield stress, when we're looking at this flow, the idea is to see the flow, right? So the yield stress tells us the power that we need to see our flow. Now the rheometer is a benchtop instrument. So this is something that you would be working on in a lab, either in your quality lab or your R&D lab.
So you're testing what is going to be getting used.
Exactly.
Right, okay.
Right? And then you figure out what the theoretical limits are behind this, and this helps to build the thickeners, because everybody's looking to build a modular thickener these days, right? Depending, again, because of that sample dependency, it's not a one-size-fits-all. Right. Especially depending on different types of mines, right?
So you're going to have to be making adjustments on the thickener depending on what's going to be coming in or out.
Now, while we can't measure rheological properties inline, Anton Paar also has inline process sensors.
Okay.
So this is, as you alluded to, density. So we have an instrument, it's called the L-DENS, which I think, if I remember correctly, the L stands for line, and the DENS, of course, is density. So we're measuring the density.
Sometimes you just got to keep it simple.
Right? Simplicity is one of the greatest things, most underrated things in life, I think. You know?
Yeah.
I come from a physics background, and one of my early career...
It's funny that you said, because when you were explaining stuff at the beginning, I sensed some physics in the flow of the way you did information, but then I wasn't sure, so I kept my mouth shut. But there you go. So it shows.
In my early career, one of the biggest learnings I had was when you explain things in a very physics perspective and standpoint, it's like me when I started studying rheology. I'd read the rheology book and fall asleep. That was my nightcap.
Physics, it's an actual different language, though.
Exactly.
It really is a different language.
So being able to now communicate effectively with as many different stakeholders as you can, it's crucial. You had to adapt, right? Well, there's something called NLP, Neuro-Linguistic Programming, and one of their key tenets is if you're continuously being misunderstood, it's not the listener, it's you. And that's something I took to heart, again, to really understand I've been speaking a different language.
Yeah.
I need to be able to communicate and make it understood for everyone else, which I hope I'm doing to our audience today.
Yeah, and it's what I was referring to is more the setups, because I noticed when in physics you will have to set up all your parts before you can actually explain the final.
True.
And that's what I was referencing.
Thank you.
So it's called the
LDENS.
LDENS, yeah.
Right. And then we also have something called the LVIS. Now the L again for the inline and the vis now for viscosity.
Right.
So many people know about viscometers, rotational viscometers, meaning you basically put a spindle in and it rotates in one direction. And from this is we're able to tell you the viscosity of any liquid. Now, if I start getting super technical, I'm not sure if the audience will appreciate this.
There'll be one guy that'll know what you're saying.
There might be one, but you think about these materials as being Newtonian or non-Newtonian. So Newtonian is something like water, something meaning it has ideal flow. When you think about something non-Newtonian, it has flow, but there's also an elastic component to it. And that's where the yield stress comes back to it for us. Remember our toothpaste, right? Yep. So the toothpaste, when you think about elastic and a material, it's like your toothpaste. It goes out and comes back in, right? That's the elastic part to it, but it also has the flow. So that's where the rheometer comes into play, because it gives you not just the rotational side of things. You can also do this oscillatory, where you're moving back and forth. And from this is where you're able to understand more about the yield stress in addition to the flow of the material. So once you have that, viscosity is a known parameter. So as it's flowing and as it's moving, we're able to measure that viscosity in line. It helps to keep us at site, in step with what was figured out in lab.
Okay, so now kind of zooming out of those three elements. So there's Viz, line, and lab. Okay. So if you take those, now someone comes walking up to here today. Are you talking to the company developing that's actually manufacturing the thickener? Are you talking to the mine operator after the thickener's already been installed? Is it both? What's the setup for it? Well, actually, let's go back to the lab. The labs, where just the testing happens, is that before the thickener even gets chosen for what it's going to be, because you need to test it first? Let's start with lab.
The lab side is constantly ongoing. Okay. Because, again, I think we alluded to it a little bit earlier, that as thickeners and thickener technology has evolved, we're looking for something more modular. So before a thickener is chosen, we would be having a conversation at any stage, really. So
greenfield, brownfield production.
Exactly. Right. Exactly. Again, because it's going to be crucial depending on the site, right? Right. So what we have at a diamond mine is not necessarily what you have a gold or a potash or somewhere else, right? So when you say we're speaking to someone from a thickener, we fit at every stage. At every stage. And if there's process improvement as well. So the thickener has not been... Right, that goes to that operating mine, that now you're maybe not dealing with the manufacturer, let's say you're dealing with the operator. And we need to optimize the process. Right. It starts in the field, but somebody else needs to be working behind the scenes to, again, optimize everything that we're working with. So we'd be talking to both sides behind this to kind of figure out, from the scientific principle where we fit in. Let's not change every variable all at once. Right. And that would be for the other two as well. Like viscosity, that's applicable at any stage. Exactly. Yeah, because if someone didn't have that measurement for some reason, 30-year-old mine or whatever, they need to upgrade their sensor technology in that, then you would apply. Or if they're starting anew, they're at the greenfield planning, they're trying to apply for permits, they can say this is going to be a more sustainable solution, all of that sort of thing. And there's an intermediary step there as well, because right now we've been talking about the inflow and the outflow. But what happens in the actual thickener? Right. Right? Now, my guess is they started calling it a thickener because you need to put an additive in there, right? Which, again, I'd call it a thickener. Now, this additive, as I'd call it to keep things a little bit clear for us, it's usually composed of a floc or a flocculant, some type of a coagulant. I'll explain a little bit more about that in a couple minutes. Some type of activated carbon. And usually this floc that we're putting in, or the coagulant, it's some type of a polymer. Now, the activated carbon is put in there to absorb any of the vapors that would be coming in, because we have a lot of different acids, different organic solvents that are being used in the process. So the activated carbon absorbs these vapors. the coagulant or the flocculant, this polymerized material that we're putting in there, that's being put in there to create flocks. Now, the way I think about it, I call the coagulant what we dose in, and I call the flock the product therefrom. So we put this coagulant in, and what it does is it has a charge. So remember when we were learning about magnets and charges?
Do I remember?
Yeah.
Yeah, I do.
So what happens when you have positive and positive?
Don't know. Do you know? I don't get to quiz. You don't get to quiz me on the show.
Oh, come on! I thought we were going to banter a little bit here.
Well, there's a reason I ask questions I don't get asked because then I get shown up very quick.
I'm with you. Well, opposites attract,
right?
If we think about it from the romantic sense, if we can take it there. So when we have a positive and a positive, they repel each other. Mm-hmm. If you have a positive and a negative, they attract. So that's why when we put this charge in, we're looking for these charges to be opposite charges. So that now all of the fine particles, like the sands or silts or clays, whatever you have in there, they're attracted to this polymer or this coagulant. And it forms this big thing called a flock. And as these bigger things get formed up, they can now be caught by the filters. And they can sediment out, or depending on how the process is set up, because every thickener works differently, but they can sediment out and then get caught by the filter, whatever it is. But the idea is to create this flock to get it out of the water. Mm-hmm. Now, the problem with this is the coagulants are very expensive. And because you're working with the charge and you're trying to optimize the amount of charge, we have a negative versus positive or vice versa, so that we're maximizing this flocculation process, as it's called. People could be spending a ton of money where they're putting in too much negative or putting in too much positive, and you're just spinning and rubber's not meeting road. So we have an instrument called the Light Sizer 500. And one of the measuring principles on this is something called zeta potential. Now, zeta potential measures the net electrostatic charge in a system. So if we take a step back and look at it another way, people look at zeta potential generally to measure stability.
Okay.
Now, if you think about a beverage, for example, a cannabis beverage, which is an emulsion where you have a CBD emulsion in there, we want the CBD particles to be well dispersed, to have it stable over time so that it's manufactured. Somebody goes out, buys a CBD beverage, they imbibe this, and they have the desired effect.
Right.
If the particles in there aren't well stabilized and it crashes out over the shelf life, you drink it, you imbibe it, and nothing happens. Right. Bad idea, not stable, right? Now, that's generally people want stability. Now, when we're looking at the flocculation and the coagulants, we want instability. That's what we're trying to create here. So the good thing about measuring the zeta potential is you can assign a number to it. And it's very simple. If the number, which is a charge, we measure in millivolts, if it's between negative 30 and positive 30, the closer we get to zero, the greater that instability, which is what we want. Because we want that sedimentation. We want these larger particles to be changing, smaller particles becoming larger particles and then disappearing. We want that instability. So as we can assign a number to it, we know how close we are to that level of instability and to optimize the process of the flocculation and eventually the sedimentation therefrom. And that's what zeta potential measurements from the Light Sizer 500 would be able to do. You're also able to monitor the particle size as well, depending on the range and the size of the flocks that you're forming out. Because again, as we maximize the instability, we could make the sizes a lot larger, right? So because again, everything's getting attracted and clumping together behind this. So coming back to your question about whether this is something that's done in the field on site versus in the lab, it's not just about the flow and the rheological side of things. There could be that intermediary step where, as we're having the conversation and the process isn't running well, maybe there's something else to consider in between those pumps.
Right.
And again, that's where the ability to keep the lab in step with the field works well. So it's always a collaboration.
Now, when you say always, is it always ever just done piecemeal, like just one part, or is it always done? Do all those pieces work together? Like, I mean, more just from a project base.
Sure.
If the mine operator comes up to you at this event, is that if you're talking about one, does it automatically mean you're talking about the other?
Not necessarily one you're talking about the other. You can lead the conversation that way, but again, this is probably me coming from a sales background and seeing things very from a very different perspective.
Right.
If you hire a rheologist, for example, and they're very focused on that yield strength and the flow curves, that's where their primary focus would be. Not to say they're unaware of zeta potential; it's just not their primary focus.
Right. Yeah.
So the conversation can be moved in that direction. So it's not necessarily distinct. They do feed into each other. It just depends on how you guide the conversation, depending on the person you're speaking with. For example, the guy running the pump, he's not thinking about coag. He's not thinking about flux.
Right.
Right? But maybe he knows somebody who is. Maybe he's working at the filter guys. Maybe they have filters attached to the pumps that he needs to think about. So it's an ongoing conversation.
So just to start to wrap up, who are you actually in these scenarios you're setting up? Who are you talking to at an actual I imagine with the manufacturers, if they're listening to it, they'd already know who needs to be talked to. But who are you talking to as an actual mine, to an operating mine, or a mine at greenfield or brownfield or whatever stage they are?
Interesting question. If I think about it statistically, we would be talking more to a project manager. Okay. That would be the higher level. Then the second level, we'd probably be talking to a lab manager.
Right.
And this
so
lab...
there'd be sort of as the stages of development it goes in.
Yes.
Yeah.
Exactly.
Okay. And that, so initial contact, would it be like project managers at this event that you'd end up talking to, or you trying to get their contact sort of thing, I guess?
Usually at this event, the project managers, unfortunately, don't have the privilege of traveling to trade shows, right? Exactly. So we'd probably be talking to consultants, because usually big companies, they talk to a consultant, say, hey, we have this issue. Can you guide us onto this? So we'd be speaking to some consultants. We'd be speaking to anybody else to learn who they're working with, because there would usually be some director level, some managers, some sales managers. A lot is what you see at trade shows, right? Yeah. So very often, I'm not telling tales out of school here, but everybody, you talk to somebody from sales. Oh yeah, I'll get you in contact with my colleagues. And,
right. Yeah. I've never done that to someone when I worked in sales. We've all done it. Yeah, I think I saw the fingers, toes, and eyes all across there at the same time. Eh? Yeah. No, it is because it is such a technical field that you're in. Yeah. I was just curious about that process of actually getting to talk to the right person, and they can sort of, if you're talking to someone like me, I might be able to understand just enough to go, okay, you need to talk to this person. Yep. But is that one of the challenges of coming to an event like this, is finding that right person, or at least building that relationship where the sales manager will actually take it and get it to the next person? Sure, I think so. And this leads me back to a thought about your initial conversation, is what's helped Anton Paar over the years. Yeah. And a big part of that has always been our collaboration with industry and our collaboration with academia as well. The bulk of our sales force are coming from technical backgrounds. Yeah, I realized that from the last episode we did, and I became very aware. I said, I'm not talking to another sales guy, which I've had lots of sales, so it's not a derogatory in any way. Not at all. Not at all. But I realized quite quickly, this is at another level. Yeah. And it's being able to have that conversation, and it may be too strong of a word, but being able to educate the people with whom you're sharing conversations about various topics. For example, as we started talking about the rheological side, you ask the question, are they thinking about the amount of coag they're using, how much money they're spending on that? Maybe they are, maybe they're not, right? But, at least you're able to continue the conversation, or start some thought process. Yeah, that's sort of that technical sales assist process that can, at least tell you can explain exactly who you need to talk to. Exactly. If nothing else. Exactly. It's been a great discussion. Before we started, I said, don't hesitate to go technical. I know you could have even gone more technical, but it is what our audience wants, because the people are trying to watch us. They're hours and hours of footage. They've heard all the leadership and all the other stuff. Sure. But this technical information is so key for our industry, and actually people sitting down and talking through it. So thank you very much for coming on. I hope it's not the last time we do it. I hope it's not the last time either. Thank you so much for the conversation. Thank you, sir. Looking forward to our next chat. Yes. Okay, and thank you everybody for watching. That's a great episode, lots of fun, and we hope we do it again. Please keep supporting the show, and thank you for your support. Thank you for all the sponsors, and we will see you on the next episode of Mining Now.